Good morning, children. So in previous lecture, we had done till question number 9.2. So let us move on. Today, we are going to start with question number 10.1. Here the question says, find the sum of 32 terms of an AP. So we have to find the sum of first 32 terms of an AP, whose third term is 1 and the sixth term is minus 11. Okay, so we know that formula of Sn is n upon 2 in bracket 2 times a1 plus n minus 1 into d. So I know n, that means 32 terms, but I don't know a1 and I don't know the common difference d. So here we are given that a3 is equal to 1, that means a1 plus 2d is equal to 1. a6 is minus 11, that means a1 plus 5d is equal to minus 11. Okay, I've got two equations. When I solve these two, I can get a1 and d. Okay, so now I have got n, that is 32. I've got a1, okay, and I will get my d also. So when you solve these two, you'll get a1 is equal to 9, okay, and your d will be minus 4. And you know this formula, just substitute the values and you get the answer. That's all. Now question number 2, okay, find the sum of all numbers between 100 and 200 which are divisible by 7. Okay, so here we don't know which number will be the first after 100, okay, and which would be the last before 200. Okay, but we know the common difference because you know that 7, 14, 21, 28 and so on, these are divisible by 7, and you can see what is the difference between them, 7. Yes, so here in this case also, any number between 100 and 200 divisible by 7, okay, when you write them, okay, in order, then you'll find that common difference will be 7. So here I know the common difference, it is 7. The only thing is I don't know the first term, okay, and I don't know how many numbers are there in between 100 and 200 which are divisible by 7. Okay, so here first term between 100 and 200 divisible by 7 is equal to 105. So how did we find that? So here 100 is there. Now we have to find a number which will be greater than 100. Okay, first number greater than 100 and divisible by 7. So you take 100, divide by 7, and at the end you will get remainder 2. Okay, so instead of getting remainder 2, if you had got remainder 7, okay, then you would have found that the number would have been completely divisible. So in order to make this remainder 7, how much I should add to it? I should add 5. So this 5 should be added to this 100. So I get 105. So 105 is the first number after between 100 and 200 which is divisible by 7. So I got my first number. Okay, now let's see the last term. Last term between 100 and 200 divisible by 7 is 196. So how to find that? So we'll take 200, we will divide by 7. Okay, so we get this remainder, we get 4. Okay, so in this case we need a number less than 200. Okay, so I have to make this remainder 0. So how much I should subtract from this so that I can get remainder 0? I should subtract 4. Okay, so 200 minus 4 will be 196. So the last term is 196. So we got that last term, but still we don't know how many terms are there, okay, between 100 and 200 which are divisible by 7. But I know the last term. So I have to take this to be as the nth term. I will take this as nth term. Okay, so n is equal to 196. Then a1 plus n minus 1 into d is equal to 196. I know the first term, I know the d. Simplify this and you'll get n equal to 14. That means there are 14 numbers between 100 and 200 which are divisible by 7. Okay, now you simply either use this or this. Okay, and you will get the sum of all the numbers lying between 100 and 200 divisible by 7. Okay. Question number 12.1. If m times the mth term of an AP is equal to n times its nth term, prove that the m plus nth term of an AP is 0. So this is a question of proving. Okay, so here it's saying that the mth term, so if you take m times the mth term, okay, then that would be equal to n times its nth term. and then we have to prove that in that case prove that m plus nth term of that AP will be 0. Okay, so let us move on according to the given information. Okay, so here given that m times the mth term is equal to n times the nth term. So this is how we'll write. Okay, m into am is equal to n into an. Now am, the mth term, can be written a1 plus in bracket m minus 1 into d, okay, by the definition of general term, and an can be written as a1 plus n minus 1 into d. Okay, now you simplify this, open the bracket, okay, and bring everything on your left hand side. Okay, and then when you'll simplify, okay, at the end you just go through these steps. Okay, if you have any problem, then later on you can ask me. Okay, but after simplifying that, you'll get like this. Okay, m minus n into a1 plus m plus n minus 1 into d is equal to 0. Okay, now m minus n cannot be 0, so in this case either this or this has to be 0, but m minus n cannot be 0 because these two are different numbers. Okay, m and n are not equal, so obviously that difference won't be equal to 0. So that means this has to be 0, this part has to be 0. So that means a1 plus m plus n minus 1 into d has to be 0. So this is nothing but the m plus nth term equal to 0. So we proved it. So please go through these steps. Okay, if you have any problem, you can always ask me. Now before we move on to the next question, these three formulae, okay, you are always you are supposed to remember this. Okay, sum of first n natural numbers, okay, sum of first n natural number is given by this formula, n into n plus 1 upon 2. Okay, if you remember in class 10 in banking, okay, in banking chapter, this was used. Okay, this formula was used. Okay, so sum of first n natural number is given by n into n plus 1 upon 2. Okay, and sum of squares of first n natural numbers, okay, sum of squares of first natural number n natural number is given by this, n into in bracket n plus 1 into in bracket 2n plus 1 upon 6, and sum of cube of first n natural numbers is given by n into in bracket n plus 1 upon 2 whole square. So this is easy to remember because if you remember this one, okay, so for the cube you have to simply take the square. Okay, this question formula 2, it might take time to remember. Okay, but first and the third one is easy. Okay, now let us see question number 13. Find the sum of each of the following series. So here we have to find sum of this 1 plus 2 plus 3 plus dash plus 200. So here you can see that clearly you are finding the sum of this 200 natural numbers. Yes, so you will use this first formula. Okay, so here n is 200. Okay, we know that 1 plus 2 plus 3 dash n is equal to n times n plus 1 upon 2. So here n is 200. Okay, so simply you substitute the values and you get the answer. Here 1 square plus this plus 20 square. So in this you have to use the second formula. Okay, so here in place of n you have 20. Okay, so use this formula, substitute the values, you will get the answer. Third one is this. Okay, so you have to use the third formula, substitute the values. Okay, this is the formula. Here your n is 10, put the values and you'll get the answer. Okay, question number 14.1. What is the common difference of an AP whose first term is 1 and last term is 50 and the sum of all the terms is 204? So here they are asking you to find the common difference of an AP whose first term is known to you. So you know A1 is equal to 1 and the last term you know AN is equal to 50. Okay, and they are saying the sum of all the term is 204. So here right now I don't know the common difference. I don't know how many terms are added to get this 204. Okay, the only thing is I know the last term and I know the first term. So let's see. Given A1 is equal to 1 and the last term is 50, and next they are saying that they are saying that total sum is 204. Okay, and here what we are doing that Let total number of terms be n, then n is equal to 50, because we don't know how many terms are there. So, but we know last term is 50. So I'm supposing that there are n terms. Okay, so that means I have to write n equal to 50. Okay, and next they are saying that sum of those n terms is 204. Okay, so we know we have the formula for Sn. Okay, and we have got two formulae. Okay, one formula is there where the first term and the last term is involved, so we will use this. Okay, because here first and the last one is involved, and I know the first and I know the last one. Okay, so in that case I have to only find n. So n upon 2 in bracket a1 plus the last term, okay, is equal to 204. Put the values and you get the value of n equal to 8. That means there are altogether 8 terms. Okay, there are 8 terms. Clear? Now next, an is equal to 50. Okay, so n is equal to 50, and you know n is nothing but now it is 8. Yes, so a1 plus n minus 1 into d is equal to 50. Substitute the values. You know a1, that is 1. You know n, that is 8. Okay, you know the n, that is 8. And now you simplify this and you get the value of d. So d is equal to 7 over here. Okay. Next, question number 14.2. The third term of an AP is 7 and the seventh term exceeds 3 times the third term by 2. Okay, so here third term, that means A3 is equal to 7, and the seventh term exceeds 3 times the third term by 2. Okay, so A7 will be 3 times, okay, it will be 3 times the third term plus 2. Okay, find the first term, okay, the common difference and the sum of first 20 terms. Okay, so here we have to find the first term, we have to find the common difference, and we have to find the sum of first 20 terms. So according to question, A3 is equal to 7 and A7 is 3 times the third term plus 2, because here it says the seventh term exceeds 3 times the third term by 2. Okay, so I have got A7 is equal to this 23, because A1 I know it's 7, so A7 came 23, A3 is 7, so A3 is equal to 7 implies A1 plus 2D is equal to 7, A7 equal to 23 implies A1 plus 6D is equal to 23. Now from these two equations I can find A1 and D. Okay, so solve these two and you will get D equal to 4 and A1 equal to minus 1. Done. Now you have to find the sum of first 20 terms. So simply use the formula, substitute the values, and you will get the answer. Okay. Now question number 14.3. The sum of the first 15 terms of an AP is 105. So S15 is 105. And the sum of the next 15 terms is 7. It is 780. Okay. And sum of the next 15 terms is 780. So that means altogether there are 30 terms. Okay, there are 30 terms, and sum of the first 15 term is 105. And then when you take sum from 16th term onwards, okay, then you get 780. So they want you to find the first 3 terms of an AP. Okay, so in order to find the first 3 terms of an AP, you should be knowing the first term and you should be knowing the common difference. Yes. So here given A1 plus A2 plus dash 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 plus A15 is 105. Okay, so this A1 plus dash dash plus A15 is nothing but 15 upon 2 in bracket 2 times the 2 times A1 plus 15 minus 1 into D is equal to 105. Okay, simplify this and you get 2A1 plus 14D is equal to 14.1. Okay, I could have divided throughout by 2, but I have left. Okay, this would help me later on in simplifying. Okay, and further, when you are taking sum from 16th term onwards, then A16 plus A17 plus A30 is 780. Okay, that means 15 upon 2, because altogether how many terms are there? 15 terms. So 15 upon 2 into 2 times A1. So if for this series, A1 is what? A16. Yes, the first term in this series is A16. That's why 2 into A16 plus 15 minus 1 into D is equal to 780. Simplify this, and at the end you will see this A16 can be written as A1 plus 15D, okay, plus 14D is this. Now simplify this and you get 2A1 plus 30D plus 14D is equal to 104. Okay, I have left it like this only. Why? Because I can see 14D involved over here, 14D involved over here. So when I'll subtract, these two will get cancelled. Okay. So now, and even this 2A1 and this 2A1 will get cancelled. So easily I can get value of D. So from equation 2 minus equation 1 gives 30D is equal to 90. So D equal to 3. So I got the value of D. Now use this D either in 2 or 1, equation 1 or 2, and you can get the value of A1. So A1 is coming minus 14. So now you know A1 and you know D. Now easily you can write your A1, A2, A3. Okay. Now question number 19.2. The sum of the first 6 terms. The sum of the first 6 terms of an AP is 42. That means S6 is 42. The ratio of the 10th to the 30th term of the AP is 1 upon 3. Calculate the first term and the 13th term. So here the sum of first 6 terms is equal to 42. That means S6 equal to 42. And S6 means what? 6 upon 2 into 2 times the first term plus 5D is equal to 42. Simplify this, you get 2 times A1 plus 5D is equal to 14. Next, what they have given? They have given the ratio of the 10th term to the 30th term is 1 by 3. Okay. So next, A10 upon A30 is equal to 1 upon 3. A10 can be written A1 plus 9D. A30 can be written A1 plus 29D equal to 1 by 3. Cross multiply, simplify, and here you get A1 equal to D. Okay. So A1 equal to D. So in equation 1, okay, in place of D, you can write A1. Yes. So from equation 1 to A1 plus 5A1 is equal to 14. That means A1 is equal to 2. So A1 is 2 and you know that A1 is equal to D. So that means D is also equal to 2. So you got A1 and D. Okay. And they want you to calculate the sum of find the first term and the 30th term. Okay. So first term is found. Now 30th term is this. A13 is equal to A1 plus 12D. So simply put the values and you will get the answer. Okay. Next question is from the same exercise but C part. Question number 3. Show that number 1, 2 plus 4 plus 6 plus 8 plus dash 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 2 n terms is equal to n into n plus 1. Okay. So here I've got a series. Okay. And it has got n terms. This. So they're saying that you have to show that when you add this series, okay, up to n terms, then the sum will be given by this rule. Okay. So this is the series, and they are saying that if you add this series till the nth terms, okay, if you add n terms, okay, of this series, then the sum will be given by this rule, n into in bracket n plus 1. So here nth term, okay, by seeing these terms, okay, you should be able to write the nth term. Okay. So here if you observe that this is 2, this is 4, this is 6. Okay. So here it is, if you have to write the next term, you have to add 2 to this previous term. Yes. Getting it? Or you can see that this is the first term. So 2 1s are 2. This is the second term. 2 2s are 4. Okay. This is the third term. 2 3s are 6. This is the fourth term. So 2 4s are 8. So if I have to write nth term, then I have to write n into 2. Okay. So here nth term is n into 2. So 2n. So 2 plus 4 plus 6 plus 8 dash 2n. Why 2n? Because the nth term will be 2n. Here we have to write the sum for the n terms. Okay. So first I should know what should be the nth term. So if you observe this, then you'll find that if you have to write the third term, then you have to write 2 into 3. If you have to write the fourth term, then you have to write 2 into 4. So I want to write the nth term. That means I have to write 2 into n. So 2 plus 4 plus 6 plus 8 plus 2n, okay, equal to, this whole thing can be written in summation form, okay. So summation n equal to 1 till n. So here n is starting from n, okay. That counting will start from 1 and the counting will go till n, okay. So here n equal to n to n, okay, and here each term will follow which rule? This 2n, okay. So here if I put n equal to 1, then this would become 2, okay, then plus, then if I put n equal to 2, then it will become 4, that means 2 plus 4, okay. If I put n equal to 3, then it will be 2 plus 4 plus 6, okay. So this series can be written in summation form in this manner, okay. Now 2 is constant, okay, 2 is a constant, so that 2 will come out as common, so 2 comes out. Now we are left with summation n equal to 1 to n, and here n, okay. So this means that if I put n equal to 1, so I'll get 1, then summation sign, that means plus, then when I put n equal to 2, then I'll get 2, then I'll put n equal to 3, then I'll get 3, plus so on till n. So I get 2 into in bracket 1 plus 2 plus 3 plus n, okay. And you know this sum is given by n into n plus 1 upon 2. Now this 2 and this 2 will get cancelled, so we are left with n into n plus 1, okay. So that's how this is proved, okay. So this is all for today.